Alrighty, so let's talk about the moon phases. Two things you need to know first. Whenever we're talking about years and days in space, the time is relative. So, astronomically speaking, a year is how long it takes a planet or a moon to complete one revolution around whatever it is orbiting. A year on Earth is 365 days because that's how long it takes Earth to revolve around the sun once. And a year on the moon is about 29 days, 27 days, because that's how long it takes the moon to revolve around us once. So, whenever we're talking about revolution, we're talking about years, we're talking about how long it takes to orbit. Now, with the days, a day is how long it takes a planet to rotate once on its axis. So it's important that you remember the difference. Revolution is orbiting, rotation is days. A day on Earth is about 24 Earth hours because that's how long it takes us to spin around one time. And weirdly enough, a day on the moon is as long as its month, 27, 29 days, because that's how long it takes the moon to spin around one time. That means a moon's year is as long as its day. And that weird timing is pretty much why we only see one side of, like, the same side of the moon all the time, because the same side is always facing us, because that's how long it takes the moon to spin around one whole time. Alright, so why does the moon go through phases? The moon isn't growing or shrinking in size, it's not in shadow, it's just that we only see certain parts of it lit up because of the angle that we are facing the moon at and the angle where the sun is as well. It's all about angles. So if you were to float on top of the solar system and look down at our Earth, Moon, and Sun from the bird's eye view, this picture is what you would see. So in this diagram, the sun is on the left side, which means the left side of all of these moons is lit up. All the moon phases look the same from space. And if you look at the Earth, you can see that the daytime side is right here on the left and the nighttime side is over here. So if I'm standing right where my little arrow is, this would be like 12 noon, and then as the Earth spins counterclockwise, it would move here. This would be like sunset, this would be midnight, this would be sunrise, and so on and so forth. Now if the sun was on the right side, then the right side of all these moons would be lit up, and this would basically be like a mirror image. Now from Earth, we see obviously different things. The moon always half lit up all the time. The new moon is going to be our first moon phase. So if you look at the new moon here from the bird's eye view of space, if I'm standing right here on the Earth looking at the moon, I only see the dark part, which is why the moon looks completely dark. Now if I am standing right here where my arrow is and I look at the waxing crescent, I can see a little bit of light here on the left side from the bird's eye view of space, but I'm on the upside down part of Earth, so we have to flip this. So from Earth, you see the right side a little bit lit up, but from space, it's still the half and half. The left side is lit up. And this is called the waxing crescent. It's waxing. The phases are considered waxing if the light is getting bigger. The phases are waning if the light is getting smaller. And whenever you have a waxing phase, the light is going to be on your right side. Whenever you have a waning phase, the light is going to be on the left side. So our next phase is the first quarter. We say it's the first quarter because at this point, a moon is a quarter of the way done with its revolution around us. Again, if I am standing on the Earth right here looking up at the moon, I see the half and half now, but remember we're upside down still, so we still see the right side lit up from Earth's perspective. The waxing gibbous comes next. Again, we're upside down, but most of the moon is lit up now. So we see this. It's a gibbous if the moon is more than half lit up. It's a quarter if half of it is lit up, and it's a crescent if less than half of it is lit up. And then we get over here to the full moon. Again, if I'm standing right here, all I see is the part of the moon that is completely lit up. And then up here, we are no longer upside down, so we no longer have to flip kind of the images that we see in our head. So if I'm standing right here, I see the moon like this. I see most of the left side lit up now with a little bit of the darkness on the right side. That's your waning gibbous, because again, more than half of the moon is lit up, but the light is now shrinking, so it's waning now. And then you have the third quarter. Again, I'm standing here. I'm looking at the moon, and I see half of it's lit up, half of it's dark. And then the last one, I see the waning crescent from right here. Just a little bit of the left side is lit up, with most of it being dark. And then you would go back to the new moon, and it starts all over again. So again, to repeat, this is what you see from the bird's eye view of space, but you see different phases from Earth's perspective because of the different angles. A moon's year is as long as its day, meaning that this time it takes the moon to revolve around us once is how long it takes the moon to spin around one complete time on its own. The moon is waning if the light is getting smaller. It's waxing if the light is getting bigger. And with your waxing phases, the light will always be on the right side. With waning, the light will be on the left side.